It has been given to me by the question that the volume of this model is equal to K. When the volume of this model consists of the hemisphere, okay, so it is going to be half of 4 over 3 pi r cube. Okay, plus the cylinder. Cylinder is going to be pi r square of h. This is equal to K. Okay, so 2 over 3 of pi r cube plus pi r square h. This is equal to K. Okay, let's try to express h in terms of r. So h is going to be equal to K minus 2 over 3 pi r cube divided by pi r square, or h I can also rewrite it as K over pi r square minus away 2 over 3 of r. Okay, with this h, I'm going to try to re-express the surface area in terms of purely just r. Okay, the surface area is A, and A is going to be equal to the surface area of the hemisphere, which is half of 4 pi r square plus the curved surface area of the cylinder, which is 2 pi r multiplied by h, then plus the bottom. Okay, the bottom surface, that is going to be pi r square. Okay, so h is going to be equal to this and this. It is 2 pi r square plus 2 pi r h plus pi r square. This and this I can combine to 3 pi r square plus 2 pi h. I'm going to replace it. Okay, so 2 pi r of k over pi r square minus 2 over 3 of r. Okay, so this is equal to 3 pi r square. Multiplying this in, I will be getting 2k over r minus away 4 over 3 pi r square. Okay, so simplifying this, we will be getting a 5 over 3 pi r square plus 2k over r. Okay, the question says that the area here, it is going to be a minimum. Okay, which means that we are going to do differentiation dA dr and let dA dr be equal to 0. Okay, that is the value of r that we want to obtain. So dA dr, okay, it is going to be equal to, differentiating this with respect to r, I will be getting a 10 over 3 pi r. Okay, differentiating this with respect to r, we'll be getting a minus 2k over r squared. And I'm going to let dA over dr be equal to 0. So 10 over 3 pi r minus 2k over r squared, this is equal to 0. What we can do is, I'm going to try to make r the subject. So 2k over r squared, this is going to be equal to 10 over 3 pi r, which means that r cubed is going to be equal to 6k over 10 pi, which is 3k over 5 pi. So r is going to be cube root of 3k over 5 pi. This is almost the value of r. It is just that we got to try to verify that this r is going to cause the area to be a minimum. Okay, so I'm going to use the second derivative test. Let's try to differentiate this one more time. Okay, so d square a over dr square. Okay, this is going to be 10 over 3 pi. Okay, and this, I will be getting a positive 4k over r to the power of 3. Okay, since r is positive, okay, so since this is a plus, this is positive, this is positive. Okay, since k is the volume. Okay, so substituting this value of r in, this entire expression here is also going to be positive. So this is bigger than 0 because r itself is bigger than 0. Okay, that is why I know a is going to be a minimum. Okay, which means that the r that is going to answer my question, it is this value. So r is cube root of 3k over 5 pi. Okay, we need to find r, we need to find h, okay, when minimum of a happens. So we will sub this r back into here. Okay, so h is going to be equal to k over pi of r square. So it is cube root of square root of 3k over 5 pi square minus 2 over 3 of cube root of 3k over 5 pi. Okay, so this I'm going to be getting a k over, I'm going to get a k over pi of cube root of 5 pi over 3k square minus 2 over 3 cube root of 3k over 5 pi. Okay, so this is the value of h and this is the value of r, or expression, okay, expression of h and expression of r.